Hi, this is Gunasekaran, Assistant Professor of Mechanical Engineering at SNS Institutions. Now we are seeing about fatigue strength of helical spring. Okay, this is a continuity part of introduction to spring. This is a part 4. We have done by 3 videos. This is part 4. Okay, now we are going to see fatigue strength of helical spring. Okay. The fatigue strength of helical spring refers to the ability to withstand repeated loading cycles without failure due to material fatigue. Okay, this endurance limit is critical as spring often operate under dynamic conditions, experiencing cycle stress such as compression and tension. Okay, repeated loading and stress rates. Helical spring undergoes cyclic loading where the stress alternative between maximum and minimum values. The stress range delta or sigma is difference between the maximum and minimum stress levels. The cycling induces microscopic crack and damage within the material, leading to failure if the stress exceeds the spring fatigue limit. Okay, endurance limit, it is the maximum stress amplitude that a spring can endure indefinitely without failing under cyclic loading. Okay, it references the threshold below which the spring theoretically has infinite fatigue life. Determining the endurance limit involved conducting fatigue test where spring subjected to varying stress level, okay, until failure occur. Then factors influence fatigue strength, material properties, surface conditions and design parameters. Understanding these factors is crucial for designing helical spring that meet durability requirement in applications such as automotive, suspension, industrial machineries and aerospace system. Engineering calculation and fatigue testing are essential to ensuring spring operate safely and reliably under cyclic load conditions. Okay. Now, seeing design consideration for helical spring. First, material selections. Designing helical spring involves critical consideration to ensure optimal performance and longevity. Starting with material selection. Now, material properties. Choose material with suitable tensile strength, fatigue resistance and elasticity for the intended applications. High carbon steels like music wires, here ASTM A228, offer excellent strength and durability for general purpose spring. Okay. Stainless steel, example AISI 302 and 316 provide corrosion resistant, ideal for humid or corrosive environment. Fatigue resistance, consider the expected number of cycle and stress level the spring endure. Material with high fatigue limits like chromium silicon ASTM A401 or chromium vanadium ASTM A231 are prepared for application involving frequent loading cycling. Okay. Surface finishing, smooth surface reduced stress concentrations and potential failure points. Proper stress relieving treatment can enhance fatigue life. Okay. Design consideration of helical spring. Here, spring index, it means mean coil diameter to the wire diameter in a helical spring. It influences the mechanical properties and performance characteristics of spring. A higher spring index ratio greater than 4 typically result in a more compact spring with fewer coil, suitable for applications where space is limited. Okay. Then stress analysis. Stress analysis involves assessing how force or load applied to a structural or component affect in its internal stress and deformations. Engineering uses mathematical calculations, computer simulations such as finite element analysis (FEA) and experimental method to determining stress distribution, periodic potential failure points, and ensuring the design meets safely and performance criteria. Okay, here K as for stress analysis, including identifying critical stress concentrations, evaluating material properties under different loading conditions, and optimizing design to minimize stress level. It is crucial in various engineering disciplines such as mechanical, civil, aerospace, and material science to ensuring structure and component withstand operational demands without failure or excessive deformations. Okay. Finally, we are seeing about fatigue life to the number of cycles or durations. Okay. Of repeated stress a material or component can enduring before failing due to fatigue. It is influenced by factors such as stress amplitude, mean stress level, material properties, surface conditions, and environmental factors. Understanding fatigue life is a crucial engineering for predicting the longevity and reliability of structural and component subject to cycle loading, such as machinery parts, bridges, and aerospace components. Okay. Engineers employing fatigue testing, mathematical models, and simulation techniques to assess and improve fatigue resistance, ensuring design meet durability requirement and operational expectation their intended service life. Okay.